This exercise will be concerning the IRIS RBI dashboard, and in particular the general reports part of the dashboard. In order to perform this exercise, I'm going to provide you with a little bit of background to the dashboard. So the IRIS RBI dashboard is a new feature which has been made, and in this instance is enabled for the ESCOM RBI methodology, and it is shown in the side pane in a special way. So in order to display the options for the RBI dashboard, one needs to use the method selector. And if I would go to the method selector and I selected the methodology to be shown as the ESCOM RBI EN 16991 methodology, what you will notice is now you have the dashboard pane, which is shown up here. So if it is on anything else, if it is on API RBI or combined or anything else, this pane shouldn't show up. So to access the dashboard, one would need to be on the start page and select in the method ESCOM RBI EN 16991. Once you have that, you can access the dashboard. You can expand the options that you have there. What will be shown to you is basically the starting area of the dashboard, and these are the main areas of the dashboard, which I will go through now. Again, in the side pane, we have our tree structure of an organization, in this case ESCOM, the power stations. Here on the very left, or the very right side, I'm sorry, we have a selector which shows us the types of reports which we can generate. And in this exercise, we're going to focus on these two panes, the reports pane and the level driver pane. These are concerning the general reports, which I will demonstrate to you. And here we have the main, basically report area or chart area, where the charts will be displayed based on the dataset selection that the user makes. So what else do we have here? We have the tree, and basically we're going to have two types of reports that we can generate, and I'm going to show you something quickly to demonstrate that. So if we expand Letabo again, and Unit 4, and Boiler in this instance, you have on the one side, you have the option to select one or multiple datasets by checking next to the appropriate name. Now, an important point here is, in order to display these general reports, these reports are pulling their information from the master analysis, from the data store in the database containing the most current accepted data. And to access anything on the master analysis, you just have to tick or untick basically anything that is not an analysis. These are the analyses. So this is used for basically for the part A or part A, part B comparison, the pre and post outage comparison. So anything you want to display with the general reports, you're going to go and select your data set and pull down the different types of reports, through which I will go in just a minute. So you want to, for example, compare, or you want to show the results of the whole of R0 power station. You select R0 power station. Or alternatively, if you would like to go and compare R0 Unit 6 boiler with Letabo Unit 4 boiler, you would select these two stations, R0 Unit 6 boiler and Letabo Unit 4 boiler. So for anything related to these buttons, in the top two panes for the general reports, you would go basically over the master analysis data, which you are accessing by ticking on the specific unit or on the specific station. The next part, which will be covered in another exercise, is the pre and post outage review. And this is why we have also the analyses within this tree of the dashboard. So in the case when we're going to do that, and we will cover this in the next session, you would, for example, select a pre and post outage assessment of a boiler, and then use these special pre and post outage report buttons to get those kinds of reports. So now, to get to the different types of reports that we have. For a lot of these, or most of these general reports, we can select what is going to be shown for us. We can select the level and the driver. So we can show level 1 results or level 2 results, and then we can show the safety consequences and the safety risk or the business risk with the business consequences. The type of reports that we have, just quickly, are basically risk status all, which will show us a torus kind of diagram showing the number of high, medium, low, negligible risk components in our selected data set. We can split it by plant, so we'll be able to split these results by, for example, stations or different stations in units in plant areas based on the selections we make on the left side. Then we have a report called Assessment Completeness All, and I'm going to get into a bit more details about that. This is a report which is going to show you how much you have assessed versus what you still need to assess, and I'm going to go into more detail about the criteria for this. And you can, of course, also split these results by plant. And then there is another report, which is the Cumulative Risk Report, which is just basically showing the overall risk within your current selected data set and how many components comprise which percentage of the risk within this selected data set. So without further ado, we're going to go and go through each of these reports in turn. So I will show you all of the reports and what one can do with them. If I were to go to risk status all, as I said, this is just in one chart or one graph showing the risk status of all of the selections that I have made here on the side. So I'm going to start off with something simple and easy like Letabo Unit 4 boiler. Say, for example, I'm interested in the risk status of the boiler. Keep in mind that this is pulling the latest assessment information we have for Letabo Unit 4 boiler, which would have, in this case, been the Part B, the post-outage assessment. So that is essentially what you're seeing. If I go to risk status all, I am in this case on level 1, and I am on the safety risk. So it's showing me basically a chart which is saying on level 1, and for safety, for safety consequences and safety risks, we have basically the number of components and into which risk areas they have landed after assessment, or at what we have arrived. So we have mostly low-risk components, some medium-risk components, and some high-risk components, which is kind of consistent with what we expect. For these components, all of these components below, you will be able to see within tables, and then you have your basically the path of a particular component, which is defined by its comp ID, its location code, and its descriptive name, and you can see which damage mechanism this was, and what was the level of risk. Was it medium, or low, or high, and so on. This is what you can get with this kind of chart. This little area here, assessed, required to assess, is also something that is tied to the assessment completeness. So maybe I can just say a few words about this. Basically, in this case, on level 1, what we say, what is required to assess? On level 1, components which are required to be assessed would be all components which, after the SANS hazard categorization, have been categorized as category 1, 2, 3, or 4 components. And the number of assessed components in this case is basically the number of components with these defined hazard categories that actually have a risk score. So they have a probability and a consequence calculated. In this case, you can see that not all components have been assessed that should have been assessed. Now, in Eskom's case, this is mostly now due to a change in the procedure under which previously SANS Category 1 components were not required for assessment, and we have now changed this because due to the newest developments with the procedure and with the Eskom RBI process, Category 1 components in the future will have to be assessed. So this gives you a tracking of how many components you've assessed, in this case on level 1, and how many you were supposed to assess based on the SANS categorization process, which is kind of like a level 0 risk assessment. So to quickly show it, I can switch between safety, or business risk, I switch the drivers with the radio buttons, and to refresh the chart, I press the button to get the same kind of report again. So these would be level 1 business risks for Letabo Unit 4 boiler. Now, I'm going to go back to safety and go on to level 2 to demonstrate some additional features. So on level 1, it's quite straightforward because each component has only one dominant, the most expected damage mechanism on level 1. So one damage mechanism and one score equals one component. On level 2, it gets a bit more interesting because components can be assessed for multiple damage mechanisms, and therefore, once we got to level 2, we could get numbers which are in some way misleading. So we would sometimes maybe get a much larger number of actual, well, let's say damage mechanisms than we have components. So to someone who doesn't know this, they would look at it and suspect and see, you know, how many components we actually have on level 2. So we have two different things that we can show. In order to show all the damage mechanisms and their risks on level 2, a little drop-down selector pops out here, and we can choose Show All DM. And then we have a second option. If we're concerned with the actual number of components on level 2, we can show the maximum risk. The Show Max Risk basically shows the one highest risk damage mechanism for every single unique component. Thus, you are again getting basically the number of components and their highest risk DM. Here, you're going to get components, and if you were to look in the table below, sometimes some component names would repeat over and over if you have multiple different damage mechanisms for this component. So I'm going to show level 2 for Letabo, safety, risk, and show all the damage mechanisms. And I'm going to go to risk status. So in this case, we have, this is showing the number of components here below, just for information. So it's again going off the max risk and counting how many of the components have at least one of their damage mechanisms assessed versus how many were required to be assessed. And in this case, we can see that actually a few more components were done than should have been done. The determining factor for level 2, for how many should be assessed, it looks at all of the ones which were calculated with a medium or high risk on level 1. These are the ones that should be assessed on level 2. Of course, one should also take this with somewhat of a grain of salt in the case that not all components have been done on level 1 yet. So there could still be some which were not even done on level 1, which maybe would have gone on and should have been done on level 2 as well. But in this case, it's showing us that more have been done than should have been done, which is basically 100%. All of the components that should have been done have been done. So now we have not calculated, and this not calculated can mean two things. It can mean that components have been browned out, as was the terminology used, which means that damage mechanisms were considered in the assessment, but were not assessed because they were found to be highly unlikely. And another case could be that really some damage mechanisms were missed. So in the future, that is going to be split, and you're going to have unlikely damage mechanisms and not calculated. So in the future, when you see unlikely damage mechanisms, you know that these damage mechanisms have actually been considered, they were found unlikely, and they were not assessed for this very reason. And then the ones which are not calculated are really the ones that you should pay attention to, which means that these might have been missed. On level 2, we have something called negligible risk, low risk, medium risk, high risk. Another feature of all of these charts, not just here in the dashboard, but anywhere within Iris, is that one can choose to switch on or switch off some of the elements from the chart. So if I choose to remove, the not calculated negligible and low risk ones, I can just get a chart which is presenting me the high risk and the medium risk ones. So this can always be selected and deselected within the legend of any of these charts. Now we go on to something slightly more interesting. So this risk status for all is basically always going to show you this kind of torus diagram. And just as a quick digression before I go on, I would like to show you the max risk. Pay attention to the numbers here. It's 42, 98, 332, 166, and so on. If I show the max risk and refresh it, I would expect to see a lower numbers in the categories, because now, yes, 16, 126, 107, it's basically showing the one highest risk damage mechanism for each component. So it's actually giving the number of components. If you were to add up all of these numbers of components, it should come up to the same numbers as down here. Now, this kind of chart, just to show you quickly, no matter how much data I select for my data set, say for example now I've selected R0 Unit 6 boiler and Letabo Unit 6 boiler, and maybe I want to go back to level 1. If I go to level 1, the little drop-down selector for max risk or show all DMs disappears, because on level 1 we only have one damage mechanism for one component. If I again go quickly to the risk status all, you will see that it again just displays one torus diagram. However, in this case, we should have a much larger number of components, because we're looking at a data set which is comprised of R0 Unit 6 boiler components and Letabo Unit 4 boiler components. And maybe a more interesting way to display this would be to split it by plants. So in this case, you get them all together. But in this case, if you split them and go risk status by plant, you start getting charts which are basically splitting your data sets by the selections that you've made in the tree. So in this case, we have on level 1 R0 boiler components, and on level 1 Letabo boiler components, and how many have come into high, medium, and low risk, and high, medium, and low risk. I suppose this is showing a large disparity in the number of components that were assessed, but Letabo and R0 are quite different designs and belong to different generations and different ages, so this can also make sense. Maybe for this kind of further demonstration, I select sister stations, which would have been Letabo and Matla power station. Matla Unit 2 boiler. And then I can maybe show the level 2. Now I'm interested in the number of components on level 2, so I'm going to go and show the max risk. And I'm going to show risk status by plant. So I'm showing the level 2 safety risks, the one maximum or dominant or highest risk per component for Letabo and Matla power stations for their boiler plants. And now we're seeing something which is very consistent, and of course these are two sister stations almost identical in design. And then we can start looking at the differences in the risk profiles. For instance, Matla has a number of more medium risk or components with a highest risk, which was medium risk compared to Letabo. And then you can start asking yourselves questions why. Now, if you were to show all damage mechanisms, again, you make the selections that you want here, and you just click the button again, and it will refresh and bring back your selection. We now will have all the damage mechanisms. So Matla actually had more damage mechanisms in total on level 2 compared to Letabo, and some of these not assessed, as I've said, were not assessed for a reason. They were found unlikely. Others may have or may not have been missed. That's basically the risk status and risk status by plant. There isn't a limitation, but keep in mind that loading very large data sets, you might have some connection issues. So you can, for example, pull in, let me try and find similar stations. So Duva, relatively similar. And maybe something like Tutuka. For, I would say, relatively similar stations. I don't know if Duva and Tutuka are maybe sister stations, but Letabo and Matla are. And if I pull, so now I have 4 stations and I'm comparing their sets. I'm going to compare their level 2 safety risks and show all of the damage mechanisms and see what I'm going to get in these sets. This is, by the way, a nice, relatively similar kind of spread of medium to high risk components. And okay, now we can start looking and seeing where we might have more problems or less problems. So at Tutuka we have quite a number of high-risk components at Duva as well, especially compared to Matla and Letabo. And you can pull in any dataset combination that you would like to choose here on the tree. For me, it makes sense to compare boiler plants to boiler plants, turbine plants to turbine plants. You can also, of course, select entire stations and compare entire stations. There is no limit to that. So if I deselected everything, I would, for example, say, okay, I'm going to assess or compare the whole of Letabo with the whole of Matla power station. And let's say I'm going to look at level 1 risk for these whole stations. Now I'm including for Letabo however many units I've got inside. For Matla, however many units I've got inside. It happens to be only the 2 units at the moment, plus some additional ones created during previous trainings. So we're comparing the whole stations, and we have roughly 1,600 components here on level 1 and 1,200 components here. Assessment completeness and assessment completeness by plant. The logic is very similar to the risk status and risk status by plant. One gives us one diagram with the entire data set, whatever we have selected, inside a torus, and one splits it by the plants or the units based on our selections. So, if we stick with Letabo and we say, yes, we say assessment completeness all, it's going to show us, now we have the whole power station, the whole of Letabo power station, unit 4 essentially, inside, and it's showing us the assessment completeness for the whole of Letabo power station, which is essentially, in this case, Letabo unit 4, boiler, turbine, Genelec, and the common plant. And it's showing how many components are assessed on level 1 versus how many should have been assessed. And this is also shown down here. So 1,842 in this case should have been assessed, and we have 1,592 assessed, which is 86%. So this is showing you your progress based on your SANS categorization in this case. Again, I repeat, this number now is mostly a result of the SANS category 1s being made being set to the status of required to be assessed, which they were not previously. So previously, only components of design hazard category 2, 3, and 4 were required to go on to level 1 assessment. So this is something that will have to be reassessed in the future. Now, if we want to start splitting and comparing and tracking by this completion between different plants, I'm again going to go to my example. Maybe I go to something else. I go to Letabo turbine plant, and I go to Matla turbine plant purely because they are sister stations, similar in design. I'm going to say assessment completeness by plant. So it's going to show me, on the one hand, Letabo unit 4 turbine plant, and on the other hand, oh sorry, I've selected Tutuka there. So I select Matla turbine, Matla unit 2 turbine. Assessment completeness by plant. Again, on level 1, and we can look at level 2 as well. So on level 1, well, we have the situation that in Matla we have, well, more components that should have been assessed versus components that were assessed. Again, most likely a result of the SANS category 1s being included as required to be assessed now on level 1. So for level 2, this is not necessary for this assessment completeness, so you just select level 2 and say assessment completeness by plant. It's again going to show the level 2, how many components that should have been done on level 2 were done for Letabo and Matla, and as you can see, basically all components that, well, again, all components that were after level 1 categorized as medium and high risk were actually done on level 2 at both stations, which is very good. So, the cumulative risk. In order to show the cumulative risk, I will go to another station, which is Camden, Unit 2, boiler. this shows a nice spread. It does not always have to be the case that this kind of nice Pareto type spread will be shown. So if I show you the cumulative risk for level 2 for Camden, and this is I always taking the max risk and showing the components. You get a cumulative risk graph of Camden Unit 2 boiler. This graph is set to if the number of components here exceeds a certain number and it becomes too many to show, it selects the top 10 or 20% or top X. So it's not going to show you always all of your components. In this case, we only do have 125 components on level 2. And again, all 125 that were assessed as medium or high risk on level 1 were subsequently assessed also on level 2. The cumulative risk graph basically takes the risk of the first component, which is this not insignificant risk, and then adds the risk of the second component, adds the risk of the third component, and so on until it comes to all of the components in this particular data set. So what it's showing you here is all of the risk in your entire set of data and how much each component contributes to that risk. Bear in mind that for the first component, this 43.82% is actually the risk of this first component, which is, I believe, a cold reheat left-hand side warming line. For the next component, everything that is up to the line of the first component is the risk of the previous first component, and the second component is basically only contributing by, well, roughly 3% more to the cumulative risk, bringing it up to 47%. And the next component is bringing it up to 50%, so it's also contributing by about 3%. And the next component also by about 3%, and so on and so on. So this cumulative risk graph serves several purposes. So you can identify your really high-risk components and the components which are contributing a lot to your entire risk within a certain plant area or the data set that you have selected. You can identify these components immediately. They stick out here. And you can set basically a risk appetite and say, okay, what is my risk appetite compared to this overall risk? Is it 60% of the risk, 80% of the risk? And you can find out the cutoff point, how many components fall within 80% of the risk. So if you have to prioritize some actions, obviously you would look at everything that is where this 80% line intersects the components. You would look at the components to the left and possibly ignore the components to the right, the much larger number of components to the right. Now, just to demonstrate how this is an example of a very nice graph which has come out. It just so happened because the risks were assessed as such in this particular plant. I would like to just show some other plants where maybe this is not so much the case. So Komati, Unit 6, boiler again. And if I go to cumulative risk, you will see that there should be, I believe, 4 components, 4 sets of boiler tubes, I believe, which were ranked extremely highly. And these 4 components are contributing to 96% of the risk. And these were some tubes which I'm not 100% certain myself, but that were gauged to be in such a position where they could possibly leak outside the boiler casing and cause fatalities. Hence, they scored extremely highly, and then everything else scored much, much lower compared to that. So again, something that is showing the user what they should maybe pay attention to. So, basically, for this exercise, I have shown you now how to get the dashboard, to select the ESCOM RBI method from the method selection tool. You may select basically any data set, so you can select your power stations, your plant areas, or your units, and you can select basically the risk status for your entire selection, or you can split it by plants or by units if you've chosen to select several plants and units. You can also show the assessment completeness for your entire selection or by plants and units, and you can show cumulative risk for, well, whatever you have in your selection. You may, of course, also select many more data sets or several plants and choose the cumulative risk, but the point being that it's always going to cut off at some point, so it doesn't make sense to select many thousands and then choose to do a cumulative risk. One last thing to add here. So if we have this tree at the moment, I will just collapse it quickly. We have the tree as it stands, and this is also going to be a theme that will be repeating in some of the other trees in the master analysis and the analyses. It will just serve a different purpose. What one can do here is right-click. Oh, a new feature, deselect all, which I was doing manually up until this moment, but so just to show you, in order to speed up the process, if you have a large number of selections, and if you right-click anywhere on any of the names, yes, you have to click on the names and say deselect all, it will deselect your whole selection. Show and hide counts. Basically, there are some counters in all of these trees, all the different trees. As we saw in the overview tree, we have the counters of the numbers of components in the different stations, units, plant areas. In the dashboard, if we show and hide the number of counts, what we are actually showing is the number of analyses. So we have 87 analyses performed within Eskom so far, and you may be able to see and identify stations from this where a pre- and post-diet outage has been performed. For instance, Matimba Power Station. If you remember, we have our structure as common plant, and then we have the unit. In the unit, we have the boiler, turbine, and Genelec areas. So here we have 8 analyses, which makes sense, which basically means that in the common plant, we have 2 analyses. We have a pre- and post outage, and then, of course, in the unit part, we have boiler, turbine, and Genelec, all of which have pre- and post outage assessments. For instance, in a station where only a part or a pre-outage assessment like Matla was done, we are going to have one analysis for common plant, and then one analysis for boiler, generator, and electrical, and turbine. So, this has been the presentation on the general reports, which can be shown in the RBI dashboard of the IRIS software. The RBI dashboard can be accessed once you select Eskom RBI EN 16991 from the method selection tool. Thank you.